Welcome back to my new video on chemical bonding and molecular shape. Please don't forget to like and subscribe to watch my new videos. Let's start. In this video, we will learn about molecular shape and VSEPR. Octet rule. We have learned in our previous video about octet rule. Atoms must obey octet rule while forming bonds. Octet rule means bonded atoms acquire 8 electrons in their valence levels. Exception to the octet rule. We assume while constructing the molecules and ions that all atoms other than hydrogen need to have 8 electrons in their valence levels as a result of bond formation. In reality, certain atoms may have fewer than 8 electrons in their valence levels when they bond. Molecules that are exceptions to the octet rule are as following. Exception to the octet rule. First molecule is BCl2, beryllium chloride, in which beryllium has 4 electrons in its valence level. Second molecule is BF3, in which boron has 6 electrons in its valence level. Third molecule is NO2, in which nitrogen has 7 electrons in its valence level. One of these electrons is unpaired. In PCl5 molecule, P, phosphorus has 10 electrons in its valence level. In SF6, sulfur has 12 electrons in its valence level. The NO2 molecule is unusual because one of its valence electrons is unpaired. Molecules and atoms with unpaired electrons are known as free radicals and very active. In living space, free radicals are known to be destructive agents and are believed to be associated with certain serious health problems. VSEPR, valence shell electron pair repulsion, is used to predict the shape of molecules and atoms made with more than 2 atoms. Molecules and ions with just 2 atoms are linear in shape. VSEPR is based on 4 premises. Shared and unshared pairs of electrons repel each other. An unshared pair of electrons repel more strongly than a shared pair. For the purpose of this model, a single, a double, and a triple bond are all considered equal. The shape of a molecule or ion is the result of the shared and unshared pairs of electrons being placed as far from each other as possible. To apply VSEPR, we look at the central atom of the molecule or ion and count the number of shared and unshared pairs of electrons that are associated with it. On this slide, there is a summarized table of the shapes of molecule and ions with no unshared pairs of electrons on the central atom. In this table, we designate the central atom as A and each atom bonded to it as B. When number of shared pairs of electrons are 2, formula is AB2, shape of molecule would be linear and bond angle is 180 degree, example CO2 and BCl2. When number of shared pairs of electrons are 3, formula is AB3, shape of molecule would be trigonal planar and bond angle is 120 degree. Examples are BF3 and NO3 minus. Number of shared pairs of electrons are 4, formula AB4, shape of molecule would be tetrahedral, bond angle is 109.5 degree. Examples are CH4, NH4 plus. When number of shared pairs are 5, formula is AB5, shape of molecule trigonal bipyramidal, bond angle 120-90 degree, example PCl5. Number of shared pairs of electrons are 6, formula AB6, shape of molecule octahedral, bond angle 90 degree, and example is SF6. On this slide, a summarized table of the shapes of molecules and ions with both shared and unshared pairs of electrons on the central atoms is given. In this table, we designate the central atom as A and each atom bonded to it as B, and the symbol E represents an unshared pairs of electrons. Number of shared pairs of electrons 2, number of unshared pairs of electrons 1, formula AB2E, shape bent, example NO2 minus. Number of shared pairs of electrons 2, number of unshared pairs 2, formula AB2E2, shape bent, example H2O. Number of shared pairs of electrons 3, number of unshared pairs of electrons. 1. Formula AB3E. Shape trigonal pyramidal. Example NH3H3O+. In our next video, we will learn about formation of bonds and orbital hybridization. Please like and subscribe to watch new videos. Bye.